Hey, hi everyone. I just got a go ahead to start. Sorry to keep you guys waiting. Uh, can anyone confirm? Am I audible?
Yes, Arif, your screen is clear. Sound is very good.
Awesome.
You can,
Thank you for the
you
confirmation. Cool. Cool. So let's start then. So here we will be talking about a little introduction about attacking AWS cloud. So my name is Mohammad Arif. I'm a senior product security engineer at Poshmark. Also, I'm volunteer at CSET Security Conference. This is my Twitter handle. If you want to connect, feel free to do so. Good. So without wasting time, let's go ahead and start. Good. So the very first thing that we need to understand, just a minute, let me, okay, I think we are good. So let's understand, first of all, what is the pen testing requirement for the AWS? So can you pen test all AWS services? The crisp answer is no. You need a permission to do so from the AWS. Otherwise, there could be a legal complications, right? Then, second most important thing is finding a weakness in the structure itself is difficult rather than finding a misconfiguration. You can take a very simple example like there is a Jenkins software. Finding a CV in a Jenkins software is a bit harder than finding a misconfiguration done by a company who is using that particular Jenkins, right? They have not configured authentication properly. They were using default credentials, correct? So that's why in AWS we are more when we say pen testing for the AWS, we are more tends to find out the misconfiguration done by those organizations rather than pen testing their particular services. Okay. There's this guideline provided by the Amazon. Feel free to check. So they have they have defined that what can be tested and how it can be tested. Coming to the next important part is AWS security, okay, AWS security responsibility model. So AWS tell us that all the responsibility do not belong to the AWS, as AWS and the customer are together in this, and so there are few responsibility which holds up customer and there are few responsibility which AWS holds up. So if you're able to see this chart, you can see the customer data is totally dependent upon customer. So how the customer is managing the data in the AWS, either they are using encryption, right? They are using HTTPS, that's on customer. Whereas AWS will take care of the compute service, the storage service, their region, their availability zone, the hardware, right? But the client side data and the other things is the customer he need to take care. So AWS create a boundary separation for the roles and responsibility. Now let's say uh, there's a AWS and in AWS you have used a default credential and now you got hacked. Now that responsibility of managing those keys belongs to customer. We cannot say to the AWS that, okay, this is an issue from your side, right? So that's how the AWS shared responsibility model works. Uh, guys, any question? question? Cool. We'll take it as no. Okay. So this AWS shared responsibility model is very basic thing which applies to everything in the AWS, right? Okay. So let's first talk about what is region and availability zone. So who have worked on AWS, they're gonna hear this more often that there are some services which are regional and there is a region, there is availability zone. In very simple language, region is a geographical area, right? So for example, your S3 data is being saved in one particular region. And there are so AWS keep on doing research, R&D, and they create new service. But their services are not available in all the region. So you will be able to find most of their services in all the region, but there is still lot of services which are only in their specific region. And availability zone is one or more data center in that particular geographical region. So this image will help you to understand more. So let's take an example of Asia specific. In the Asia specific, there is a region called Mumbai region. In the Mumbai region also, there are three availability zones. So they have done this to ensure disaster management. Now, in let's say Mumbai specific region, there are three distinct places where their data center is present. Let's say due to the flood or some earthquake or natural disaster, one of their data center got down. They still have their two more data center present. So this is the general practice by the most of the organization that they divide their services into multiple region as well as the multiple data zone so that sorry availability zone so that in case of any natural disaster they still have their application live. Okay, so the very first thing about pen testing anything is all about recon, right? So recognition, in a simple way, recognition is a method to collect the data. Uh, I like to play this video. So, so if you see this, right, so we can implicate from this that there are people who are trying to ask him something and he's trying to get the data and he's looking around the places where he can get and provide that, right? That's all about recon. So in order to find certain data or to exploit certain things, you need to have resources. You need to find attack surface. With the help of the recon, you do so. Now we'll see how we do the recon in cloud. So while doing the recon in the cloud, you look for the hard-coded secrets, sensitive data, and other misconfiguration. We'll talk about what are them. So the very first one is the hard-coded secret. So many developer has done this mistake. They have hard-coded their secret access key, credential, API keys, session tokens, right, in all over the places. And hackers are tend to get those details. They search into the web, they do dorking, they look into various platforms, they look into the commented code, GitHub, right, Jenkins, Kibana, all these places to find out those secrets. And that secret help them to easily access or get into the system, right? So it is very important. We should never do hard coding. If we are doing, we should be using a password manager or some secure places to store it. And I've seen a lot of people have putting all these things in the public record. So once it is public, anyone can in the internet can scan and look into it. Uh, Moving to the next, sensitive data. So in the cloud recon, uh, we try to look for any public S3 bucket available, or any bucket which has an public object which can be done, right? There are cases where EBS storage were publicly exposed, and AMIs and snapshots were publicly exposed. People just go into the AWS console and they search for the AMIs in a snapshot. They get the list, then they, with the AMI snapshot, they create EC2, and then they try to look into what are the things available present. And in many cases, they have found out SSH keys and all. Through that, they have got access to the other resources. As it's sensitive data is always sensitive, we should always protect them, right? We should make sure that our S3 buckets are not public. Even though, let's say we have a data in S3 bucket, we should be encrypting that, right? That's same narrative we say, right? When we store a password in a database, we should always encrypt those data if they are PII data, because there would be chances where your database will be hacked and the records will be all to the hackers. But if you have implemented a second layer of security, that is the encryption of data, it will make more harder for the hackers or the malicious actors to hold that data. Right? Uh, Moving to the next, there are other misconfigurations, right? There could be misconfiguration like you have made misconfigured IAM, you have used bad architecture VPCs, right? Let's say you have, instead of making private EC2 as a backend server, you have made it public. Now anyone can ping to that, can perform DDoS attack, and if it has a lot of other issues, then uh, it's like a open market for the people to scan and then hack it, right? Use of IMDS v1, and there are other misconfiguration like you have not uh, you have not configured properly CloudTrail. CloudTrail is another AWS service which help you. It's you can understand is as a logging service, which will have all the logs of the APIs, everything you perform, right? So if you have not configured it, let's say there is a attack that happened, you will never get to know what was the initial factor, how it came, at what privilege, what are the other privilege it has taken up. Right? So these comes as a other misconfiguration which you can look for while pen testing AWS. So the security we use is on the left side, right? And the security we should ensure is on the right side, right? So this is what makes your AWS architecture or your organization more secure. So let me take you to the couple of case studies. One of the greatest case study was the Code Spaces. It was uh, a hosting collaboration platform. It's a UK based company. Back in 2014, I guess, there was an attack on them, a DDoS attack. So attacker have got the access of their EC2 panel, and then through that keys, once they hold that keys, they mail to the company owners and ask for ransom. But company decided not to. So and they uh, since they got to know through their investigation that it had happened because of the credential leak. They tried to change the credential, but the attackers have made multiple backdoor into the control panel. So once the organization changed that credential, those attackers they have deleted the S3 bucket, EC2 instance, EBS snapshot, all the resources in that AWS account. And they have almost deleted l- all the backups and all the configuration, all the customer data. So in the press conference, they said that although we have got back the access, but attackers have deleted all the data, and it was up to this point that they have to close their business. So this was a huge impact, right? Another case study, Tesla, right? Everyone knows Elon Musk and Tesla, right? Their company also got hacked in the same manner. So they were using a open source Kubernetes console, and one of the Kubernetes console, it was unauthenticated. So attackers got to know about those, and in one of the when they go through it, they find multiple pod. In one of the pod, they got the access credential of the AWS environment, and through that AWS credential, they were able to list down and download all the S3 bucket, and those S3 bucket contains like business related data, vehicle telemetry, and a lot of other stuff. Also, they have deployed cryptojacking operation in that. They had started mining. Although later on Tesla said that they found out this vulnerability by responsible disclosure and they have taken all the measures against it. But the attacker have already done a lot of damages in the system, right? And one such hack happened to your organization, the reputation is gone down, right? So coming to the next, before this, there was one more hack that's called online data. So I think the attacker got the access of AWS credential. They found those credential in the GitHub uh, GitHub repository. So through that they got the access. The credential were working. Then they deployed a lot of deployed almost 20 EC2 machines. Those are 4x large machine. They are the most biggest machine, and they have used that uh, so to do certain operations, and that had cost them like $90,000. So they had to pay this amount to the AWS because they have used the resources. Although they have not, but the attackers have used their account. So such attacks can lead to a data damage, money damage to a company, right? Reputation damage. Coming to the next, we have a RC via SSRA. So there is an attack which was uh, called Capital One. So uh, it was one of the biggest attacks, and there are a lot of US US people voter ID and a lot of PI data have been exposed with that. And after that, the AWS has introduced a new service called IMDS V2 to mitigate that. Let's look into the case study, what had happened. So there was this attack called Capital One data breach. And due to this, 190 million customers' data were exposed. And because of such, the government has imposed 80 million of cost on the Capital One firm, right? There are more than 1,40,000 social security number, bank account number, PIA data has been exposed. So how this attack had happened? There was a SSRF issue in their application, and they were using IMDS V1. Through the SSRF, they got the credential, and they then list down all the bucket, and then they copied all the bucket. Sync is a command for the S3 operation to sync all the bucket in the AWS to your local system. Don't worry about IMDS V1. We'll soon talk about it. So before talking about IMDS V1, let's first look into what is SSRF. So when an attacker is able to craft and payload which the application, which make the application request that crafted payload is the SSRF. So if you see, when the attacker directly try to access the system, the server or the, let's say, component, he will not be able to do so because there is a DMZ zone, right? But when the attacker crafted a payload in a way that the web server further propagate that payload and execute the attack. Now, since web server has a role or a policy, you can say that it can access to this particular server, but no one other in the public can do that, right? So any request which goes through a web server will be accepted by this particular backend server. So that's how SSRF attack happened. Attacker crafted a payload in a way that your web servers making that request. If you still do not understand fully, this could give you more example. Wait. Okay. So I think you can see. So it's like a security person checking who is there, and your payload tells that I am localhost, I'm the system. Then he said, okay, since you are one of us, you can go ahead. That's exactly what is happening here. When attackers trying to directly access the resource, he was not able to do so because of the policy and the other thing, right? But when he tried to go via this part, that he made the web server to send a request to these resources, he will get a result, right? So that's how the hackers use SSRF payload in all the vulnerable application where SSRF is possible to fetch the cloud metadata, internal endpoint, they get sensitive data. They also try to scan all the internal hosts, what are the other service running upon, and then further they do a privilege escalation, checking which service is vulnerable, then they can further exploit it. So instant metadata service, let's see how this instant data service is being coupled with the SSRF to got the RC. So IMDS is one of the service by Amazon itself. A lot of the service uses that metadata. Those metadata holds like role, what is the public IP, the private IP, and all these data is being used when any other service call some service. Then the you can think like it's a initial handshake. Those data got exchanged, and based on that data, then further action had happened. So this service hold all these data, right? Which also hold the temporary credential as well. You can see user data when you initiate any EC2 machine, right? If you want that your when you run up in EC2 machine, by default it loads certain data. You define everything in that user data, and once the EC2 machine is up, it will automatically download and run that particular thing which you have defined in user data. That could be like installing Nginx, installing Jenkins. Then there are a lot of resource discovery things like your instance ID, what are the VPC you are using, what is the network configuration, everything will come up under here. So currently there are two format of IMDS, that is IMDS V1, and because of that, because of the that design, that Capital One attack had happened, and post after the Capital One attack had happened, uh, AWS has launched IMDS V2. IMDS V2 in design make uh, make little difficult for SSRF to happen. will look why. So IMTS v1, it's a simple GET request, and this is the metadata URL. It's the same like your local host, uh, 127.0.0.1. It's for the system, right? But for the cloud, this is the localhost URL, 169.254.169.254. So if you call this, and then there are paths like latest metadata and then other directories, and you just have to do a get call and you will see the data. And this is completely unauthenticated service. Now in the IMDS v2, they change the design that rather than doing a one request, we have to now do a two requests to get their data. The very first request is what we have to do. We have to create a token, and then that token will be passed as a header in the next request in order to extract the data. Now, let's say there could be a case. Okay, before that, this is a put request. This is not a get request, and this is a session oriented. You need to pass this token in order to get the data, and it has a time to live, right? After a certain period of time, it's gonna expire. By default, I think it's a 6 month, but you can again change that. Okay, so let's say there is a SSRF and there's a put request. Uh, you are able to perform a put request in the SSRF, but that's how the IMDS v2 is configured. When it will see any put request, it will change it to hop one. So basically, it's block the request. So it block any request with X forwarded header. So even though if you have a SSRF with a put request, you'll not be able to fetch this particular data. So that's how MDS v2 helps to mitigate the SSRF attack. Let's see demo. So I've created a small demo for this. Right. So this is one of the vulnerable application. I've created a vulnerable application which has a SSRF vulnerability. Okay, so I think let me copy this. I've given a little description about SSRF here, but let's go ahead. Uh, page source. So here it was hard coded that there is a path called service PDF URL which has a URL parameter, and through that we can load the internal file system, right? So let me go to this path. And we have seen there they have mentioned that there is a parameter called URL through which we're gonna access the internal file. Since we are able to access the internal file, I may try to think of a tag like where I want to retrieve other sensitive files in the application if it is allowing. That's what basically SSRF is. So I will try to do a local host in this. Since I know this is a cloud application, I will try to use a cloud localhost that is 169.254.169.254, and let's see if we get some result on it. Awesome. Uh, we are able to get the result. Okay, let's keep it in the view source only. So now we can see there are a lot of directories, right? 1.0, 2007, 0119. So these are different versions of the IMDS v1. So initially when it started with one. Now you might be thinking, Arif, what is the difference between all these, right? So the only difference between them is, let's say in the very first version, they have started with uh, giving out only IP address, public IP. But in the second one, they have started giving also instance data, the name of the data, the VPC, and let's say in the this one they also added a user data. You can also see the user data, right? So that's how the version is. So whenever you go, you look for the latest. When we go into the latest, we can see there are different there's dynamic, there's metadata, there is user data. So let's first check into the user data. What are the things? Okay. So we can see a simple bash script over there, which is saying install git, then clone this particular repo, then go into that, then start a Python server, then activate that particular Python server, then install the requirement, and then start the Flash server on port 8001, right? If you guys remember, I told you the user data is being used uh, to ensure or to say that when you want your EC2 up be running or start with certain predefined configuration. So you define those configuration in your user data, and then you just start your EC2 server, and it will automatically download or do these actions to you. Now there could be a scenario where you got the credential. We'll see how we'll get the credential, but before the think from this, that you got the credential and you are able to edit this user data, right? So you will stop the machine. Now, since you have a permission, you will be able to edit this. I will just put a listener, a backdoor here, a reversion, and then start my application, and boom, you will get the reversion, right? So that could be one way to exploit it. But in order to do that, first you need a credential so that you can log in into the AWS, right? So we'll go into the metadata. And if you see into the metadata, now you have a lot of items here which you can look for. The very one I want to show you is, let's check what is the host name of the. So this is the host name. This is the internal IP, right? Let's check what is the instance ID we have. Okay, so it means it's okay. Let's check something else. Okay, yeah, we got. So this is the instance ID which we have. I mean, this particular EC2 machine, right? So you can see there's a lot of data about the EC2 server which is present here. Now, what is most interesting here is our credentials. So I'll directly copy it here, and so I have given here there are a lot of this is your URL for the credential. I'll directly look into it. right? So the path is latest metadata, identity credential. Then in identity credential, what is the service it is? It is a EC2 and the security credential of that, right? Then you can see there is a access key, there is a secret key, and there is a token. Since it's a EC2 machine, yeah, it will have a token, right? And the expiration is right here. So once you got these access key and access ID, it's done. You can configure on your local system and then try to do a privilege escalation check for what other thing, what permission it has, so that you may want to pivot. Cool. Just let me show you guys this as well. So I've already configured on my local system. So I've configured this credential uh, with this profile name OWASP DEC2. So we'll just do a AWS get identity to ensure that this is the same. So I did, and this is the instance ID it has. Correct. We can check. Uh, the instance ID. Okay. So we can see this. This is the same. This one, right? FEEC1, right? So with this credential, now I am able to pivot and look into what are the things available in that EC2, right? If I have a proper permission, I can even stop this particular EC2 instance, and I can run spin up another EC2 instance. Right? So all these things you can do. Okay, we have one question. I want to ask for attacking AWS cloud. My ask is level low cloud engineer, what use MFA or change password 30 days and can low attack in AWS cloud. Uh, Riz, can you little elaborate this? Or we can take up the question at last. There is still content left. So let me quickly go through that and then we can take up the question. Cool. Okay. So now let's move ahead. First, we have seen how those credential can be used so that you can uh, check what are the permission, do the privilege escalation. Now, the another major service which is being used is the IAM. IAM basically it's a identity access management throughout your AWS resources. This is connected to all the AWS resources. It tells what authentication and what authorization it can be done. It's a global service. It does not depend upon any reason, right? Uh, so basically, in order to get into a console or to perform any action, you need two things. One is your authentication, and second thing is your authorization, right? So authorization define are what are the things you can do in the AWS. Let's move ahead. There are major major entities in the IAM would be your root account. Root account is the first account which when you create an AWS access, and by default it has all the accesses. It is recommended to never use your root account for doing any operations. You should always create IAM users or yeah, IAM user to use further. Uh, okay, then next is your IAM user. Those are the account for your team or would say for doing any operation, and they do not have any policy by default. So the root account need to uh, put permission on them. Then IAM group. Maybe you don't want to give uh, permission to one people. So basically, group help you to manage a lot of people. In group there will be a lot of IAM user, and then you can implement one policy in the group uh, that will be inherited by all those IAM users, rather than giving policies to each and every user, which will make the DevOps, I mean, it will make difficult to manage all those IAM user. We can give it to one group, which will be inherited by all the IAM user. Then your IAM role. Okay, in the IAM group, two people can be part of same group which are part of two different groups as well. For example, one is part of dev team. One group I've made as a dev team, another group I've made a DevOps team, and that same person can be part of dev team as well as DevOps team. Second, third is your sorry, fourth is your IAM roles, right? So let's say your EC2 machine want to do some write and data on S3 bucket. So it need a role. It need a trust relationship which tells that what it can do and at what on what resources it can do. So that's come to your role. You can give role to the uh, IAM users as well and IAM services as well. And your IAM policies. IAM policies. Let's move ahead in that. It's more clear. Okay. Before to move ahead, IAM policy is just a JSON document which tells us what is going to be done. We'll look into in depth what is IAM policy and how it is defined. So this is your overview. So if let's say there's someone who wanted to access the AWS resources or the console, uh, there are two ways. Either they can go via client browser where they have to use username or password, or if they want to use the CLI, then they have to use access key and secret. And let's say there is a resource, then you also have a token. Like in our case, we have EC2 machine, which has a token as well. Okay, so okay. So this is how AWS root account look. Root account is accessed by the email. So if let's say you have your email exposed, then you can also you will be prone to this sort of attack if you have not enabled MFA, right? So it's always recommended not to use your root account and always protect your root account with high priority, right? Put MFA on it, create IAM user to do operations, because if your root account got hacked, now the attacker would be able to delete all the resources, everything, every IAM user, everything, right? So it's very necessary and very important. You have to protect it. And let's say if you get hacked, even though AWS cannot recover that. Once it is deleted, it is deleted. So we need to very securely configure this. So as I said, IAM policy is a JSON document which just tell what the permission it has, right? Uh, you can make up to 5 versions of the policies, and we should always follow the least privilege permission. Least privilege principle is like, let's say a dev has only need to access the EC2. Then we have a database team. those database team do not need to have access to EC2, but they only have access to database. So the policy I will define that my dev group user will only able to access EC2, not database, whereas my database user will only have access to the database, not the EC2. That is called least privilege principle. Okay. Now your policy have a different components like SID, effect, action, resource, condition, which tell what who can access, what can access, what condition will be there, and then this policy are applied to user group. You can put it to role, you can put it to the user, you can also put it to the resource. So let's see this sample policy structure. That's how your AWS policy look like. The very first one is the policy language version. Version is just like Python 3.1 has a certain structure, right? Python 2 will have a little bit different structure. So with this particular version, this is the structure. Then your ID basically it's an identifier for your policy, what you want to give it the name. Then statement is what are the things you're gonna define in that particular policy. SID is again the statement identifier. So you can put multiple statement in a policy, like as we have done here. So they are identified with the SIDs. Then effect is the main thing in the policy uh, which helps the AWS to say like whether you want to able to allow this resource or you want to deny, right? So effect is basically to allow or deny. Then your principal is who can, like what account, what user, what service you want this policy to be applied. Let's say you want this policy to be applied to EC2 machine. Then here in the AWS, you have a EC2 on. If you want to apply this policy to particular IAM user, your IAM users on will be here. On is again a unique identifier for that particular service or a user. Then next is your action. What action you can perform with particular this. So currently we have in this S3 get object and put object. We can get the object and we can also we can fetch the object and we can also upload the object. Coming to the next is your resource. So on what resource you can perform action. So currently here we have on S3 my bucket and we have asterisk. So it means I can perform this particular action in this particular S3 resource, which has a name of bucket, and under this bucket, every object I can perform this S3 get object and S3 put object operations. Then we also have a condition. So when this condition is met, only then this policy effective. So I can define, let's say I want to only do operation when there is a IP address which has a source IP of this particular range. So only when the IP come with this particular range, this action will happen. And let's say if the IP is completely out of this range, when they try to perform this action, this will be denied. So let's see a couple of IAM misconfiguration. The very biggest misconfiguration which people have done, and it's not like people are not doing, people are still doing this. So we need to be very careful about it, because initially when they set up our application, they tried to do with this and then they left it as it is. Right? And there are many times when we try to debug the application, why it's not giving, then we try to give more excessive permission in order that application should run, and then we leave it at it is. But this could lead to very disaster. So the very first thing, a strict means all action. Now you have an action, strict resource action. So any action can be performed and on any resource you can perform, right? Action could be like your uh, listing S3, deleting S3, listing EC2, deleting S3 through creating access keys, right? And resource could be anything, S3, EC2, RDS, Route 53, right? So this over permissive policy we should never define. Now let's come to the next, where you have an action which is STS assume role. So one can perform STS assume role, but in the resource we have defined strict. So one can perform STS assume role on any resources, right? So we should not also configure like this, because if somebody has this policy, then he can do ton of action on any of the resources. Let's say now dev guy will have access of assume role to the database, to S3 and the other, right? Which we do not certainly want, because we should all, for the security, we should always use least privilege principle. Uh, Coming to next, let's see this particular policy. In this particular policy, we have defined a principal. Principal is the person whom we are defining the policy, right? So in this AWS star, and then we have defined I am root user. Again, we should never use the root user, right? Then what action he has? He has STS assume role, which I've seen in the last. But now this STS assume role can be uh, summoned by anyone, everyone, basically, right? So these kind of misconfiguration in the IAM, which we see regularly. There are other misconfiguration like you are using AWS managed policy like IAM full access, S3 full access. They have a lot of fine grind policies in it. But when you give S3 full access, they have access to all the thing, including your creating, deleting, updating, right? So we should be very particular about what policy we are defining for the particular user and for the particular resource. Okay. So how the policy evaluation logic works, it so it's basically check whether is there any explicit denies is there or not. And if let's say there is an explicit denied in the policy, then it will override everything else. So we'll see an example. So this is an example where we have in SID1, there is a effect called deny. Action on S3 star, this action can be done. Resource star, right? And in the SID2, we have effect allow. What action can be performed? That is S3 put object and resources star. So in the first SID, we can do all the S3 operation. In the second, we can only do put object. Sorry, in the first, all the S3 option effect is denied. So if I come to the conclusion of this, can we perform the S3 list bucket operation here? The answer is no, because in the first SID, we have denied everything in the S3. So S3 list bucket will also not happen. Now come to the next. S3 put object operation can be performed. We can see here the effect is allowed in the action of S3 put object. But since we have explicit deny in the first, which is S3 star, everything in S3 is in deny. This will override this. So hence we cannot perform this. And can we perform IAM list user here? No, we cannot, because it's not mentioned. So when it is not mentioned, you cannot do that particular operation, right? So I think we are already with the time, but I will take few more minutes. I will just quickly cover them. So there are few misconfiguration in S3. S3 is again one of the major service being used. It's a simple storage service. You have a bucket and a storage in that. Uh, it's like a, if you've seen the Doraemon, it's like a pocket. You can put every object, but yes, you have to pay the Amazon for that. There are few case studies like Accenture has publicly exposed S3 bucket, which has the data decryption key, authentication, credit, or API data of their customer. There was one more Republican data analytic firm. They have they were using S3 bucket. They were storing PIA data of the people, American voter people. Uh, right. So that was also exposed. That was found out. It has nearly 198 million records. Then the third case study was the agent run. It was a CMS, customer managed service for the insurance broker, and they were holding this public S3 bucket which contained the health and medical data. Uh, Including the health and medical data, they also had like what are the doses, uh, what are the income range of that particular person, what are the ethnicity of that particular person, right? So we should be very careful when we are using such services, because if they are not configured properly, I mean, the disaster could be tremendous. The few issues in the S3 would be making the bucket public. So you have given a public read permission, and second, you give a public write permission, right? Public read permission, anyone have the URL of that particular bucket can access it. Anyone who have a right for, I mean, anyone who has the URL can write on that particular bucket, right? So let's say you created a bucket and you have given it a public read and public write. Now anyone can read what is that, but also they can write into it. Attackers can use it as a storage unit. They will put their data into that, and then through that they can read it, but the cost will incur on you because that particular bucket belongs to you, right? uh, if you're using a CLI, you can just try with the AWS S3 ls will list down all the bucket, and this is the nomenclature for S3 bucket, S3 colon slash slash and the bucket name. Sometimes just doing this will not work, so you need to mention no sign request, which means it is a unauthenticated request. And if it is a publicly exposed, you will be able to say this. Then there is a issue where you have configured a bucket, you have not configured public bucket, but you're configured in a way that all the AWS authenticated user can see it or write into it. It means anyone who has a valid AWS account with his credential, he can access, he can read, he can write. There are other operation also, like you can copy, you can upload the data, you can delete even buckets. So all thing can be done. And the other misconfiguration, you're like you're not maintaining a version. So if you're not maintaining a version, if somebody change it, you will now never able to restore it. You're not using encryption. That let's say you are putting a PII data, and somehow that bucket got publicly exposed. All the PII data got exposed. Since it's not encrypted, anyone can see it. Then improper ACL, as ACL is your access control list. So S3 has a bucket and then it has an object. Now ACL can be applied to all the objects. So let's say one particular object you want to make it public and another object you don't want to make it public. So you can implement the ACL. If the proper ACL is not defined, then that could again misconfiguration. One more scenario for S3 is S3 issue is S3 bucket takeover. So let's say company create a bucket and then they have mentioned in their Route 53 account, and after certain time, uh, the backend team they deleted that particular bucket. They do not want, but your record is still present in Route 53. Now anyone can look into that bucket, and if it sees that it is available, then they can create it. Now, let's say if I found out that this particular bucket was not present and it is available, I can create it and I will load my data into it. Once I load the data, it will reflect on their URL. Right? So this is a major uh, case for S3 bucket takeover. Uh, you have a couple of practice vulnerable cloud. I've put a link over here. AWS Cloud Build Plus, Rhino Security Labs. You can try and practice over there. And then we have a lot of automated cloud pen test tool which do all these operations in automated fashion. Prowler, Cloud Mapper, Scout Suite, Cloud Custodian are a couple of them. But you can look into this particular resource, which is Arsenal of AWS Sec. You will find a lot of good resources over here. Uh, right? You will find the labs and the other thing. This is one of the good resource to start. Yep. Thank you guys. That's all. And sorry, I took a little bit more time. Guys, if you have any question, feel free to ask. Even if not now, then you can always connect to me on LinkedIn or Twitter and ask me there as well.